guys, we are Team Paradox, and our problem statement ID is SIH 1637. Our problem statement ID is development of AML-based models for predicting prices. So, what is the idea title? We are going to use an arima-based model to predict the future agricultural commodity prices. What arima-based model does is that it will take the historical data and it will predict the price in the future dates which are not currently in the data set. Technical approach. We are going to use technologies. We are going to use languages such as Python, HTML, CSS, JavaScript. APIs such as transmodel.api is used to import the Arima-based model. Database, MySQL, PostgreSQL, etc. Libraries, we are going to use React.js, Node.js, Scikit-learn, Pandas, NumPy, Matplotlib, etc. Model deployment, cloud platform, AWS, Google Cloud, etc. We will first collect the data, then pre-process it, then we will develop a model, then we will predict the model and then deploy it. Feasibility and viability. Feasibility depends on the available data and advancements and how good we are going to update our model. The key challenges are inconsistent data, market complexity, and if our model is going to sustain in the market or not. We will address these challenges by improving our data quality. We will use more advanced ML techniques, and we will boost stakeholder trust with training and insights. Impact and benefits. We can use this model to help farmers. What farmers can do is that they can know when and where to buy crops that are cheap, when they should sell their crops. Government can use this to predict when to release a stock in market to stabilize the price of crops. Traders can use this to predict the price and have a much needed profit. They always make. Social, economic, and environmental benefits, improve income stability, reduce waste, stabilize food prices, etc. Research and references. So here are two research papers that we have read and based on it. Now here is the image of our site algorithm that holds the basis of our ARIMA model. And here is the final result of what we will predict in the model. I would be explaining the machine learning model, ARIMA model behind a site. So first we import all the necessary libraries. We also import matplotlib.pyplot for our machine learning ARIMA-based model importation. Then we take the model price and price date columns to specify in a data frame. We will use only these two models to train a data set. Now, what we use is that we will take model price for entire month on average. Like we will take for January an entire average price and we will use it for the whole of January. Now, what we are doing here is that PDQ. What is PDQ? So, PDQ basically the parameters that control the ARIMA-based model. Here we are use S ARIMA X for seasonal ARIMA. Here is an example of the iterations of PDQ. So we will calculate PDQ and we will then train our model MOD. We will then find the AIC value by using the PDQ iterations. The lower the AIC value, the better is the model. So now we will use date to predict. That is, we will input the date from which we want to predict. We will train our data from 1990 onwards in a data set. New the data to predict will be future data, not present in a data set. Here we are using one step ahead forecast, and in the end of our model, we have trained our model as such so that it predicts the lower modal price, the modal price, and the predicted price. So here is the final graph. Mind you, we will be predicting the upper modal price and the lower modal price. This is the highest value it can go and lowest value it can go any day. Thank you. And we have also used and made other models to predict the crops, such as barley crop prediction, rice crop prediction, soy crop prediction, and onion crop prediction.
Name is Vedant Singh. This front-end site, AgriTech, has a feature, a leaf logo with four main pages: home, about, dashboard, settings, and it includes a sign-in system that counts how many users are active. Means we are six members in a team and we all logged in, so it's showing six active users. We also uploaded 10 CSV files and the CSV file includes how many data it also shows here. The site uses authentication to show which country the user is from. So let's move in the dashboard section. Users can see their profile images and names along with their names. There is a filtered section in which there is a commodity option, input option, and the select date range. In the commodity options, there are many uh, commodities like wheat, barley, rice, onion, soya. So now let's move in the about section. The about page highlights the developers behind the site with links to their social profiles mainly.
Here we go on the dashboard, and let's say we select a commodity such as onion, and we turn in the date 2016-01-01, let's say, and then we enter our date. Now a graph will be represented here as I said in our model, and it will take some time as the model is running in the background. Here is a graph. So here the blue line represents the historic data, and the red line represents all the future prices. Here the red line in the upper bound is what the highest price could be on that day, and on the lower bound is what it could be the lowest. Now going on, here is the date and price. Now going to about page. Here the model explanation. So what is a PDQ? They are the PDQ is the observations or the parameters that could be used in the ARIMA based model to classify it and train it. It works on taking the historical data and predicts the future prices. Thank you.